Okay, so in this video I will explain you about the shift bit instructions. Okay, so there are two types of shift bit instructions are there. It's like left, shift to left and shift to the right. Okay, so I will take one rising edge pulse as x0. So we need to type SFTL will refers to the left, R will refers to the right. So this SFTL is instruction for shift to the left side. Okay, like and here I need to give some address. Okay, the first address is for data entry, data command, whether the bit value is true or false. For example, I will take as x1 input, and next one is the bit from where, as from which bit you have to start. Okay, for example, I will take m0 here. Next, how many bits you wanted to shift, like you wanted to shift 8 bit, 10 bits or 20 bits, so that I can take. So I will take k7. Total 7 bits I can shift from m0 to m7. Okay, not 7, m6. Okay, total 7 bits. So next, what is the shift range? Do you want to shift single bit or 2 bit? That I need to define here. Like if I give k1, so whenever I am giving the command, the bit will shift by 1 bit. So if I give 2, so it will jump to it will skip, like it will shift 2 bits. Okay, so if the value is in m0, if the m0 is true, so if the now here k2 is there, means when I give command, so the m2 will get on. Okay, so I will take only one. That means when I give command, m0 value move to the m1. So if I am giving here k2, that means m0 value move to not m1, it will move to m2. Like how many shift you want to do, that you need to define, and how many number of bit you want to shift. This is the k7, total k7, total 7 bit I want to move. Okay, so this is the shift command. So when I uh, on this, so whatever the value will be in the m0 will move to the m1. When I off and on again, same thing happen, it will shift 1 bit. So the value of m0 I can give by this input x0, sorry, x1. So if I make it x1 on, then when I on this, the value, the true value will go to the m0 in one cycle. So when I off this x1, and again when I on this input, the true value will move to the m1, from m0 to m1. It is shifting left side of the byte. Okay, total 7 bits we have taken, so the value will move up to the 7. I will show you that here. So I will take LDM0 and I will connect output to Y0, LDM1 output Y1, LDM2 output Y2, LDM3 output Y3, LDM4 output Y4, LDM5 output Y5, LDM6 output Y6. So total 7 bits I have taken, 1 2 from 0 to 6, that means total 7 bits. So I'll just compile this, and here I will on the simulator. Okay, so now m0 value is 0, that we can check here also. Like I will go here, I will type m0, so every bit value is 0 now, right? So now what I will do, I will take this, and x1 value I will make it as true here. Okay, so now I will put the command here. When I on this, so the true value directly move to the m0. So now I will off this. Okay, so in this table also we can see the true value is in 0 bit. So now same, I will off and on again. The value is move from m0 to m1. Okay, so it is moving by one number, like one bit it is shifting. So when I off, and sorry, I offered m0. Okay, so again one more time I will show you here. Now the value is in m1, so when I on again, it will move to the m2. So like this, if I move one more time, it is moving to m3. So m4, m5, m6, total 7 bit I have defined there. So when I on again, it is going to erased. So total 7 bit it moved. Okay, so now if I keep this x1 on, and if I shift that value again, here you can see it came. So again one more time I will move, so the same true value again it moved. So m0 also 1, m1 also 1. So now I will off this. So now if we shift, you can see, so 2 times it got true, right? So that's why the true value is moving. It is moving toward the left side. So up to 7 bits it will move. After 7 bit it will get erased. Okay, so this is the shift to left instruction. This is we'll use for like tracking of any object on the conveyors, or sequence control we can able to use this. Okay, similarly shift to right option also there. So in this only I will show you that instead of SFTL, I'll make it as SFTR. That means now the bit will move to the right side. So but right side we don't have any bits, right, after m0. So I will make this address m7. From 7 to it will move on the right side, 7 6 5 4 3, like that. So from here 7 6 5 4 3. Okay, just I will compile, and on the simulator here. Okay, so now the memory bit values are 0. I will on this, on. So now I will move the value on. Now we will see which bit is on. So now bit number 3 is on. Okay, so I will switch again. First, before that I will off this. So we will move only one true bit. So I will on again. So I will see it is moved to 2. Okay, off, on. So now it is moving toward right side, right? Okay, so I will one more time I will on this, and again I will move this. Now we'll see which bit is on. Okay, it is taking from okay, we'll see that. Okay, switch. Okay, let's just I will on this. I think I have selected bit here and I am controlling here. I will just off. I will off this, and I will off this, and here I will on this, and X0 I will on. Okay, okay, so I will X0 I will take, and I will off this, and I will on again. Okay, so you can see it is moving from it should move from 7, but it is moving from here, 9, 10, 11, 12, 13. So it is moving from 13. Okay, so I will off this X1. Now we will move the value X0. Now it will move false value. You can see 0 is moving. Okay, so until 7 it is moving. Okay, okay, so now I got it. Like so until here it will move. Shift to right means, so if I'm giving M7, so total 7 bit will move until M7. Okay, so if I give uh, like M M10 I will give, and total bit I will give K10. That means, so on the right hand side of this M10, the 10 bit will there, so it will move until M10. So that means M10, M11, M12, M13, M14, M15, 16, 17, 18, 19. So value will start from M19 and it will end to M10. We'll check that. I think it will work like that only. So okay, I will just on the X1 here. X1 value is 1. So now X0 I will on. So we will see the value. Okay. So in M19 you can see value came. So I will off this X1. So now we will see how it will move. I will take X0 to shift the command, shift the bit. So I will off, on again. So it is moving, you can see, until M10 it will move. If it is right side meant it will move until 10. So if it is left side, so then you can see, so now it got erased. So total right side it is moving from the M10 bit, but if it is left side move, so whatever the value is there, it will move left side of the this address. Okay, so that's about the shift bit instruction in Mitsubishi GXworks2 software. Okay, thank you.